Good day everybody, bonjour à tout le monde, that's how you say it in French anyway. And welcome back to the lab. Now however you are online but we're still in our lab, as you guys know. So I will try to go back through all the practice we did so far, so that this will help you to prepare for your second and last test. And I wish you all the best for the future. Make sure you work hard to go up to the end of this course. Because guys out there, they need you to make things happen. Okay? Then I'll take you back to the board to try to discuss everything done so far. I'll come back to the practice manual. I think I'm starting from practice 4, okay, which is level measurement. And we are required normally to identify the level control loop, point 1. So what we have to understand here is this. Let's say we have a tank. This is normally our control tank. We can only control what's coming in or what's going out, but in our lab we're controlling what was coming in the tank, process input. And we don't care about what's going out. Okay. For us to control what's coming in, we needed something, a control valve, CV. Okay. That's the one here. So CV, that's the process coming in to this tank, which we're trying to control. Again, what we need a level sensor. For instance, we have a LT, which is known as capacitor probe level sensor. Okay? The closed loop, using closed loop. So what we do, the sensor or the signal from the sensor will send to the controller, which will be our LIC, the controller. And from there, we have a set point. That will be the percentage or level in this case. Okay? Then the output from the controller here was sent to your control valve. That is your closed loop. Closed loop here. Then guys, for us to get, let's say in this instance we have water. So we had a pump there which was collecting water from the storage tank. Okay, so the storage tank here is water and water in here. So we're collecting water from this tank to the upper tank by controlling the flow. And controlling the flow also that will control our level of the sensor. Then the next section you need to be able to identify the type of sensor used. For instance, here for this application we use a capacitor probe level sensor, the one you see there. What is happening is that it's known as capacitor probe level sensor. The sensor is made of a metal strip which needs to be insulated. Okay. Then the capacitor is always made of 2 plates. So for us to make a capacitor, we had to add 1 metal probe. Why do we add that? Because our tank is plastic. Okay? If this was a metal vessel, there was no need of adding the extra probe. Then I'll answer question 3. I'll explain question 3, where we need to understand the principle of operation, how this works. By adding a second probe, we're creating a capacitance in between this probe. Okay. Now, with the increase of process, which is water, of liquid in this term, there is a change of capacitance. Then this change of a capacitance normally induces a signal output from the sensor, which is 1 to 5 volts. And this signal is proportional normally to the level in the tank. Let's say the level needs to go from 0 to 100%. Okay, level changes from 0 to 100%. On the other side, the signal from the sensor will go from 0 to 5 volt. But in engineering or in process interpretation, we don't start at 0, we start at 1. So that if we see 0, we can tell that normally the sensor is faulty. This one starts from 1 volt, 1 to 5 volts. Then this is related. Okay? It's a linear process. Because from there, you can use this graph. Let's say from 1 to 5 volts. Maybe here you can take, in instance here we're starting from 0%. 0, or can take any set point, let's say now from 0 to 100%. From there, we can be able to calculate the output voltage by using, it's a linear process. That means that when you reach 5 volts, at the level in the tank will be 100. You can say if 100% gives me, let's say 5 volt, that means 1% will give me 5 volt over 100. Then X% will be 5 over 100 multiplied by X. Let's say what will the signal output from the sensor be when the level is at 70%? That means 70% level will be 5 over 100 multiplied by 70. That will be, this is, oh God, the compressor is making some noise here. And we need a compressor for the control valve to operate, so we need those noise. I come back here. That is 1, 2, isn't it? 1.5, 2. That means this is 3.5 volts. Okay? So if the level in this tank is at 70%, I'll be expecting an output from the sensor of 3.5 volt. Let's check that. Let's prove it. Okay, I'm going to change the set point there. Our software is a MATLAB software we're using for simulation. So I'll come there, I'm going to change the set point to 70. Oh no, it was at 70. I made a mistake. Let's change it back to 70%. I'm going to put 70 there. So this is the multimeter here connected to the output of the sensor. You see guys, the level in this tank will start maybe increasing. That's 50%. It's going up. It's about 50% now. It's at 65 there. Now if you check there, we are having 3.3 volts. But we're expecting, as shown on the board, 5. Oh, thank you. So we're expecting 5.5. There, okay, there we go. That side is 70. We have reached the set point. Okay, check there now. On the multimeter we're getting 3.476. I think it's close to the calculated value. That means fine. So this is a linear process. That's how you can try to get the value. Okay, so if I have to put the set point to 50, I'm expecting a value around 2.5. Let's change to 50% and see. You enter there, you see this value must decrease. It should be around 2.5 volts. I'll observe first here. This is my set point. So I decrease to 50%. It's giving me 52. We need 50, 51. Still waiting for it to reach 50. Yeah, it's around 50 now. 50, 51, 51, 50. The valve is keep on adjusting until you get 50. You are at 51. There we go. Getting closer to 50. And if you check there we go. We have 2.51 volts. Set point there is around 50. Okay. Let me check the next point. What else we need? Measure and record. That's what we were doing. So I was measuring. First, we had to do some calculations using that simple maths. Then I'm measuring the output from the sensor, and this is your signal output from the multimeter. So if I change that value, the set point, if I change the set point to, let's say, to 70, or let's put 65, oh, I think I changed the wrong place. That's one. Change here, 65. Okay, this value need to increase. So the value will be changing between 0 and 5 volts, between 1 and 5 volts. Okay, that was for pressure sensor. Now we'll talk about the, that was for the level sensor. Now we'll go to the next prep, which will be the pressure sensor. Okay, next one is pressure sensor. That task number, let me check here. Temperature level, I think task number 4. Sorry, number 3. Task number 3, the pressure sensor. Here what you need to know is to be able to identify the control loop as well for the pressure sensor. Come this side. The pressure can be measured in the pipe or in the tank. This is marking. So what we need to do here, a closed loop, let's say we're measuring the pressure in the pipe. This is the pipe. This pipe is still the same pipe having control valve. So we have a CV there. There's a control valve in the pipe. So what we do, this is our sensor again. This time now is a pressure sensor, PT. Okay? So we have to send this to a controller. It's PIC, where we'll have a set point on the amount of pressure we want to have in the pipe. Then the output we send to the control valve. Here, by opening or closing the control valve, the pressure in this tank will change. Usually if you open the control valve up to 100%, the pressure will decrease. Remember, there's a pump pumping water from the storage tank to the control tank. Okay. Then this loop, we can still control the pressure in the pipe. So now what also you need to know, how to wire the sensor. It's very important. The pressure sensor is wired in what known as a loop powered circuit. So we need a 24 volt power supply. There you go. We need 24 volt power supply DC. And let's say I have the pipe here, and this is my sensor. I'll need a multimeter somewhere there. I need a multimeter here. What I need to know here, that the output from the sensor is current. So the sensor has polarity, plus, minus, and also it has the power supply also got polarity, plus, minus. So what you need here, the positive side of the power supply must be connected to the positive side of the sensor. And then this is your multimeter. We're looking for milliamps, the current, and then the output signal from the sensor goes to one lead, the multimeter, and the other one goes back to the power supply. This is your loop powered circuit. So if you do that, this is your pressure sensor, PT, you'll be able to get an output from 4 to 20 milliamps.